Today we're going to talk about the real number system. So your I can is I can identify the different types of numbers in the real number system. So make sure that you've filled this out on your table of contents. Pause the video if you need to. Okay, so what is the real number system? What is the importance of the real number system? The real number system is made up of all the points on a number line. The real number system is used every day. Numbers play an important part in the real world by assigning values and weighing variables. Remember, variables are like those unknown numbers that you've talked about before, like you use X instead of a number that you don't know what that number is. So let's go ahead and we're going to start here in our kind of circle. And we're going to start with the smallest one and work our way out. So the first one I see is in green, natural numbers. So if I flip it, what are natural numbers? They are positive integers. So these are the numbers that you've seen since kindergarten. You started adding and you just started counting 1, 2, 3, 4, 5, 6, 7, 20, 25, 35, 2,000. Okay, so those are positive integers, natural numbers. Let's look at what whole numbers are. Whole numbers are the same thing except it also adds 0. So a number without fractions or decimals and you're adding a 0 to it. So now it's 0, 1, 2, 3, 10, 15, 35, 2,000, okay? Now we've got integers. What are integers? A number that is not a fraction and it can be positive or negative. So integers, we are now adding those negative numbers. So negative 2050, negative 17, negative 2, negative 1, 0, 1, 2, 3, 15, 18, 25, okay? So as you can see, all natural numbers go inside whole numbers. And we add one with whole numbers that does not go in natural numbers because 0, or I'm sorry, yes, 0, okay? Then, because I'm looking at the wrong page. All right, so natural numbers are just positives. Then with whole numbers, we added 0. So all natural numbers are also whole numbers. But not all whole numbers are natural numbers because natural numbers cannot have 0. 0 goes with whole numbers. It does not go with natural numbers. So this is kind of like a Venn diagram. Think of the 0 like out here. It's in the whole number part, but it's not in the natural numbers part. Now we've got integers. So we went into whole numbers. So all whole numbers, 0, 1, 2, 3, and so on, are in integers. And remember, integers, we have now added on our negative side. So again, let's start over. Natural numbers are just those positive integers, 1, 2, 3, 18, 25, 30. Then for whole numbers, we added in the 0 as one of those. Now with integers, we've added in all our negative numbers, okay? But they all are so far into rational numbers. So let's talk about what rational numbers are. So rational numbers, a number that can be written as a ratio or factor, or fraction, or fraction, includes terminating and repeating decimals. All of these are examples of rational numbers. So rational numbers means it's a number that can be written as a fraction or a decimal that repeats or ends, okay? So let's look at this one. We've got the square root of 25. So if I had my calculator and I did 25 and the square root of 25, it is 5. It stops. 5 times 5 is 25. That's what square root of 25 means. 4/5 is a fraction, so that's a ratio there. It's good. 1.23, it's repeating, so that's okay. Includes terminating and repeating decimals. 2.425425, so it's repeating and it keeps going, so that's okay. And then we have negative 100 again, so that's fine. So again, all of these numbers, so natural numbers, whole numbers, integers, are all inside of rational numbers. It's just that not all rational numbers, like 4/5, can be an integer, whole number, or natural number. So if I gave you the number 18, if I gave you the number 18, So 18 is our number. You're gonna tell me which ones of these is it, and let's use the first letter of each word to determine what it is. Is 18 a natural number? Yes, it is. It's a positive integer, so I'm gonna put an N. Is 18 a whole number? W for this one? Yes, it is. It keeps going and includes 0. So I'm gonna put a W. Is 18 an integer? Yes, it is, because integers include negatives and positives, so I'm going to put an I. Is 18 a rational number? Yes, it is. It has any numbers that can be written as a fraction. Well, I could do 18 over 1. That's a fraction, so R. Okay, so a number can be lots of different things, but it also may not be all of them. So if I did the number... negative 18 this time, let's do that. Is negative 18 a natural number? No, because it's not positive, so it can't be a natural number. Can negative 18 be a whole number? No, because it only includes 0 in positive numbers. Can negative 18 be an integer? Yes, it can, so I'm going to put an I because it takes negative whole numbers. Is negative 18 a rational number? Yes, it is. Whole numbers, all numbers basically that work out perfectly and you can make a fraction. Can I make negative 18 into a fraction? I sure can. So I and R work for negative 18. All 4 work for positive 18. Now let's look at irrational numbers. Irrational numbers are kind of those oddball numbers, all right? They're kind of out there and we sit there going, well, geez, what are we doing with these things? So it is a real number that cannot be expressed as a ratio or fraction of integers, okay? So here's some examples. 2.1354, I cannot change this into a fraction. Pi is one of those numbers that just goes on and on and on and on and actually just never stops. And then the square root of 8. If we look at the square root of 8, so 8 square root, look at this number, all right? It doesn't work perfectly. These numbers do not go perfectly into it, so they're irrational numbers. So what you're going to do on your practice is they're going to give you 3 number lines, and you're going to put a dot anywhere where it tells you to put a dot. So plot points on the number line below that represent integers. So you would go to integers and say, okay, what are integers? They can be the negatives or the positives, and it includes 0. So let's see. Oh, -3, -2, and then I'm going to keep on going until I can't anymore. And then you're going to do the same thing for the other 2. Good luck.